I start the recording.
Okay. Okay, welcome all. Welcome to this session. This is as per the agenda. We are just making a continuous session for this technical information sharing. And the first session is it's all about wet type sprinkler system, and we are going to see the topics. These are all the topics: sprinkler introduction, types of drawing, and NFPA standard introduction, and system drawing reviews, sprinkler site inspection, WARs, some key information. The objective behind this to leverage the technical information among our teams, because in coming days we are going to be involved in cross-functional assignments. So for that reasons, whatever that mechanical, it will be shared among with the team, whatever the fire alarm or smoke management. So it will be leveraged among the team. As for the first part of it, as I said, we will start from the sprinkler system. So everyone is aware about the sprinkler system, how it operates, and in Aman, what we are actually doing, it's planned reviews and WARs. This is the core we are doing, and we are one of the, as everyone aware, we are one of the civil defense and HGIS approved consultant. And as a consultant, we are one step ahead of the contracting or installation team. So we are in a place we advise, and we are providing the solution for their issues, and we are in the stage of consulting, and we are providing ideas and the way to get out from that issue. So the sprinkler system, how we can put it in a perspective, how we are helping our clients to get their job done, and how we are ensuring the safety of that occupants is being ensured. And so this is just an overview, just an idea behind it. First introduction for the sprinkler system. There are different types of wet type system, and sprinkler system itself, dry type, wet type, and pre-action, and deluge systems are there. So the first one we are going to see wet type sprinkler system. Wet type in the sense, in the whole pipeline, it will be charged with the water. So this is end to end the function, how it is from the water tank till to the nozzle and inspector test connection. So where the water is getting from, getting into the system, it's from this water tank. So it starts from this water tank. It is being picked up by this fire pump, which is a centrifugal fire pump, and it is being discharged to through these pipelines, and it is being supplied to this. Assume this is the building, and it is being supplied to this system here. And this is the alarm check wall. These are all the pipe connections and hanger supports. You see that. And here it is inspection test wall connection, and upright sprinkler, pendant sprinkler, main risers, and riser nipples. So this just how it looks like, and it depends on the building condition, depends on the occupant, and depends on the structure of this building. It will be changed, and it will be customized according to this building. It will be customized according to this building requirement on the coverage of this location. So what is what, and in some locations, you may be not fed by the water tank. It will be from here. It centralized the system. This is a dedicated system over here. In some location, it will be fed from that underground city main water supply. In some, it will be dedicated water supply. For an just an example, I just put the dedicated water supply water tank over here, just to get an idea about it. Then when we go in detail of this wet pipe sprinkler system, what are all the components associated with this wet pipe sprinkler system and how it gets operated? So first, this is upright. These are all the pipe connections over here. This is what the alarm check wall. This is just the same check wall, but in the purpose it is giving an alarm when it gets operated. So it's called alarm check wall, ACV. We normally see it in the drawing. We call this one is a CV alarm check valve. Then this is the upstream connections where the water is going from here. It is going to the system. Below the wall, we call this is upstream. Above the wall, we call this is downstream. So this is the alarm check wall, which is intermediate, which is in between upstream and downstream. And this is control wall. Control wall means we can open and close to isolate the system. And this is what this main drain wall. And top of it, it's pipe connections. Here you will have branches in the pipe connections, upright sprinkler down. If it is downwards, it is pendant. If it is in the side wall, it will be the side wall sprinkler. And what it is the retard chamber. It is nothing but to delay the alarm activation. One can say that why we need to. One can ask why we need to delay, because whenever for example, if you see these connections, whenever the pump gets kick in, you will have some surges in the water line. So if the surge is more, your the clapper will get the flip here. This whenever there is a water, there will be a push here. Whenever there is a push, this will trigger this alarm, and also it will trigger the water motor count. If this pressure switch get activate, then it will connect to the fire alarm system. Then the fire alarm will give a notification. So if it is false, this is a nuisance alarm. So in order to avoid that kind of nuisance alarm, so this is just a mechanical delay, kind of mechanical delay. It will accumulate the water first. For example, if the water comes over here, parallelly it will go through this pipeline connection, it will go here also. And after that, once this bottle been filled, then it will go to the pressure switch, and also after that it will go through this mechanical motor valve, and after that it will be drained. And you can see one pipe is going down to the connection of a drain pipe. uh, it has this restricted orifice over here, and parallelly when it goes up, it will also a small amount of water will come down, but it is not in the same volume of water. It is having a restricted orifice, so it will not directly drain to that drain will be slower, then the fill will be faster over here. So this is one line. The other line, what it is, if you assume that there is a fire over here, the sprinkler get activate on that dedicate on the particular temperature. Then there is a starting of water flow from here. Then the water is flowing from bottom to top. Along this wave, it will create alarm. The water also will pass through this bottle. It will fill that. It will activate this. The pressure switch. Pressure switch. It's normally in NC normally open contact. Then once it is been filled, it will become normally it will become closed. The circuit will be closed. Then it will trigger the fire alarm system based on the cause and effect. So this is what actually. Yes, Asif.
Yeah, I have something to ask. The
Mm.
first question, this alarm check wall. Why
Mm.
actually we need this? What is the exactly scope of this alarm check wall? This
Yes.
is one, and
Mm.
the number two is like this drain valve is when it is used. This drain valve, any uh, any it is to drain water. This is what I understand. But like when it is required to be drained.
Mm. Yes, the
Yeah.
first question to answer why it is needed here, because if I will go back to this previous slide, from here, if you are feeding from water tank till to this line here, check wall is nothing but it is one-way wall. Once the water is being topped, then after that it will not drop down. So that is the purpose to prevent the backflow. To prevent the backflow, it is been installed. If you go here, you already charge the water here, right? You charge the water already here and you shut off the pump. Then if you don't have this check wall, you assume the black color is not there, right? And the water will drain back. water will drain back, and it will be the water will not be stable. In order to prevent the backflow, you are having that. Why we are calling this alarm check valve? When it is operating, it is also giving an alarm. So that is why we called alarm check valve. Otherwise, we would call this one as a normal check valve. And also, is it clear, Asif?
Yes, yes, yes. For this
Okay.
backflow is